Our claim is that this interaction is a chemical reaction. When the solids are lit on fire, the fire will change color and heat is released, as well as gases from the burning alcohol. Heat being released from a reaction is called an exothermic reaction, which only happens when a chemical reaction occurs. The color of the flames also changes depending on which substance is being burned. Also, when ethyl alcohol is burned, it changes into a new substance, water vapor as well as carbon dioxide. And this reaction is irreversible, also an indication of a chemical reaction occurring. Finally, the change in color further indicates that a chemical reaction occurred. One of the items used in this experiment was sodium chloride. Sodium chloride is one of the most well-known and widely used chemicals known as table salt. Sodium chloride is a white crystalline solid that has a density of 2.6 grams per milliliter and a melting point of 801 degrees Celsius. Sodium chloride is soluble in water and other solvents. It is a stable solid that only decomposes at high temperatures to give toxic fumes of hydrochloric acid and disodium oxide. However, if the fire is not too hot, the salt may still keep in solid form and just combine with the oxygen to form sodium chloride. The color that comes from burning this substance is yellow. One item used in this experiment was potassium chloride, also known as KCl. Potassium chloride is an important metal halide which is an essential electrolyte source for the body. Potassium chloride is an odorless, white, crystalline solid with a density of 1.98 grams per milliliter, a melting point of 770 degrees Celsius, and a boiling point of 1,420 degrees Celsius. KCl is highly soluble in water and a variety of polar solvents, however insoluble in many organic solvents. KCl dissolves in water and gets fully ionized into solvated K-positive and Cl-negative ions. Thus, aqueous solutions of KCl show electroconductivity, making KCl an important electrolyte in many applications. Another important reaction of KCl is used to produce metallic potassium by reducing KCl with metallic sodium at 850 degrees Celsius. The color that comes from burning the substance is purple. One item used in this experiment was borax. Borax, also known as sodium tetrabate or sodium borate, is a mineral and inorganic salt was largely used as ingredients in laundry and cleaning products. Borax is a white crystalline powder. Its melting and boiling points are 75 degrees Celsius and 320 degrees Celsius. Borax's density is 1.73 grams per milliliter. It is highly soluble in water, and borax and water forms alkaline solutions. In an acid solution, borax reacts to produce other borates, such as sodium perborate, a compound commonly used in the chemical industry. So, borax can also form boric acid. The color that comes from this substance is green. One item used in this experiment was strontium nitrate. Strontium nitrate is a white crystalline solid. It is non-combustible but accelerates burning of combustible items. It may explode if large quantities are involved in a fire or the combustible material is finely divided. It may explode under prolonged exposure to heat or fire. Toxic oxides of nitrogen are produced in these fires. Strontium nitrate is also used in pyrotechnics, medicine, and to make other chemicals. The fire that comes from this item is red. The fuel used in this experiment was methanol. Methanol is the simplest alcohol, being only a methyl group linked to a hydroxyl group. It is a light, volatile, colorless, flammable liquid with a distinctive odor very similar to that of ethanol. However, unlike ethanol, methanol is highly toxic and unfit for consumption. At room temperature, it is a polar liquid. It is used as an antifreeze, a solvent, fuel, and as a denaturant for ethanol. It is also used for producing biodiesel by transesterification reaction. The fuel used in this experiment was isopropyl alcohol. Isopropyl alcohol is a flammable, clear, colorless liquid which has a slight odor resembling that of a mixture of ethanol and acetone. It has a bitter taste, and it has a boiling point of 82.5 degrees Celsius and a melting point of negative 88.5 degrees Celsius. It is very soluble in water and it has a density of 786 kilograms per meter cubed.